This video is for the CAM operations for Titan building block 5M, setup 2 and 3. Previously, we ran setup 1, and now we need to remove the carrier and chamfer our part. Your second setup is going to be upside down. Stock is going to be 2.05 in the X, 2 in the Y. The Z is actually going to be 0.970. That's the 1 inch minus the 30 thousandths from setup 1. We want to make sure our offset from the bottom is 0 because we're going to push it all the way down to the bottom, and our work coordinate system is going to be box point, bottom, center. Flip that around, there we go. So bottom, center, X to the right, Y forward, Z up. Going to probe the bottom of the soft jaws that are already made. Stock 2.05 by 2 by 970 thousandths. Post processor is going to be 5002 for the program name. Comment, and we're going to use work offset number 2 for G55. To remove the carrier, we're going to do an adaptive toolpath, 2D or 3D, doesn't really matter, at 6,000 RPM with our 3/8 inch flat end mill. Cutting feed rate 108 inches a minute, resulting in 6 thou feet per tooth, plunging at 30 inches a minute. Geometry is going to be stock contours. Heights, pretty much standard. Bottom height's going to be model top. Passes, tolerance 4 thousandths, optimal load 80 thousandths, minimum cutting radius 20 thousandths. Actually don't need that checked. Klein milling, we got a maximum roughing step down 80 thousandths, 800 thousandths. Fine step down 80 thousandths, really doesn't even matter. Stock to lead, we're going to leave 10 thou in the axial direction, and smoothing is going to be on at 2 thousandths. Linking, this should be fine as is. That should give us a nice spiral adaptive toolpath, removing the carrier but still leaving 10 thou axial stock to lead for a finish pass. That finish pass can either be in another adaptive that's slower to get it nice and smooth, or it can be a facing operation. I have chosen a 2D pocket. 6,000 RPM, 40 inches a minute, nice and slow, nice and smooth. Plunging at 15. Geometry is going to be, this is our chain. Stock contour is going to be outside. Let me just deselect that so you can actually see what's going on. Geometry, right there. Stock contours is going to be that edge. Heights, that's fine. Tolerance 4 thousandths. All this should be fine. I did reduce the step over a little bit. Use morph spiral. This will, I think, give us starting from the center and work our way out. And we want to make sure that we're plunging. We do not need to do a helical ramp. So our tool should just spiral in and then do a pocket for the finish pass. The reason we are not chamfering in setup 2 is because we do not have the exact center location of our model, of our part. We have the center of the stock, but because we probed off of the side, the center of the stock might not actually match up with the center of our model. So we're going to do a third setup, setup number 3. The stock is going to be, instead of fixed size box, it's going to be from solid, and you click on your solid. Our post process tab is going to be 5003. We're going to use number 3. That will be G56 for our work offset. Setup is going to be a work coordinate of top center of our model, because we'll be able to probe this cylinder and get the exact center so our chamfer will be correct. Okay, typical 10 thou chamfer, 4000 RPM, 50 inches a minute, geometry. All this should be the same. Click OK. Check this simulation. Drop right down. On this one, actually, if we look at it again, since we're not chamfering in a very tight area, we don't need to chamfer right here. We can scoot this up a bit, so I'm going to go back and close that. We also don't want to run into our soft jaws, so under tip offset, I'm going to change that to 0.08 to 0.02. And now when we run our simulation, it should no more down at the bottom. This will also spread out the wear on our chamfer mill, so we're not milling in the exact same spot. Close. I'm going to go ahead and simulate everything. Turn off the model. Simulate. Turn on my stock. I don't really care about the tool path. And turn off the tool. Simulate. There's the spacing. We've already done this before. You can fast forward. You can pause and kind of scrub back and forth, left to right. You can also drag on the timeline down here to speed it up, slow it down, pause. Flip this over. Oh, that was a waste of time. I only simulated that setup. You need to make sure I simulate that. All of it, the entire setups. Also, just click right here and jump straight to that operation. Chamfer, there we go. There's our 3D adaptive. There's our 2D pocket. And then here's our G56 setup 3 for the chamfer. close. Check your tool numbers. You're going to post-process each one of these individually so you can set your work offset for setup 2, get rid of the carrier, and then probe your cylinder to set your work offset for setup 3. That is it for Titan 5M.